Google Cloud Network Infrastructure. Google's global infrastructure is one of the most powerful and advanced in the cloud industry, providing the backbone for all of its services. 1. Global Network. Google Cloud's global network infrastructure consists of high-speed fiber optic cables that span continents, undersea cables, and multiple points of presence. This infrastructure supports high-performance and low-latency connections for Google Cloud customers. 2. Data centers. Google operates data centers worldwide to ensure high availability and redundancy. These data centers are designed for efficiency and scalability, providing reliable cloud services and minimizing latency. 3. Edge locations. Edge locations, also known as points of presence, POPs, are strategically located around the globe to serve content closer to users, improving response times and service quality. Global network. Google Cloud operates one of the largest and most advanced private global networks in the world. It is designed to support high-speed, low-latency communication across Google's cloud services, ensuring seamless data flow between your services, users, and external systems. Private fiber optic network. Google owns and operates an extensive fiber optic network that spans the globe. This private backbone connects data centers across continents and powers inter-region traffic. By avoiding reliance on the public internet, Google can ensure higher reliability and security while reducing latency. Undersea cables. As part of its global network, Google also invests heavily in undersea cable systems. These cables carry the bulk of the world's data traffic between continents. Google is involved in several key subsea cable projects to enhance data flow across regions, ensuring fast data transfers and high availability. Data centers. Google's cloud services are hosted in state-of-the-art data centers distributed across various geographical regions. These data centers are designed to handle the demands of massive workloads, while ensuring redundancy, energy efficiency, and security. Global footprint. Google Cloud has data centers across multiple continents, allowing customers to deploy services close to their users to minimize latency. Each data center is strategically located to offer low-latency services to the surrounding regions. Energy efficiency. Google has made significant efforts to design its data centers with sustainability in mind. Through innovations like custom hardware, machine learning-powered cooling, and renewable energy usage, Google Cloud is one of the most energy-efficient cloud providers. High availability. Redundancy is built into Google's data center design. Each facility is equipped with multiple layers of failover systems, ensuring that even in the event of hardware failure, services remain available. 3. Regions and zones. Google Cloud's infrastructure is organized into regions and zones to help you architect highly available, fault-tolerant applications. Regions. A region is a specific geographical location where you can deploy cloud resources. Each region contains multiple zones, which are isolated data centers that provide additional fault tolerance. Zones. Zones are the individual deployment locations within a region. By distributing your workloads across multiple zones within a region, you can ensure that your application remains available even if one zone experiences a failure. Zones are connected by high bandwidth, low latency links. Example of a region and zones. The U.S. Central 1 region, for example, contains multiple zones, US Central 1A, US Central 1B, US Central 1C, etc. You can deploy your compute and storage resources across these zones for redundancy. Cross-region traffic. Google's network enables efficient and secure data transfers between regions, which can be essential for globally distributed applications. Services like Cloud Spanner and BigQuery leverage this network to deliver high availability across different regions. Edge network and points of presence. POPs. In addition to its data centers and fiber optic network, Google also operates a network of edge locations, known as points of presence, POPs. These edge locations are designed to bring content and services closer to end users, ensuring low-latency access. Edge caching. Google's Edge network caches content close to users, which significantly reduces the time it takes to deliver web pages, videos, or other assets. For example, Cloud CDN, Content Delivery Network, leverages Google's Edge network to cache and deliver content globally. Regional connectivity. POPs also play a key role in routing user traffic to the nearest Google data center, ensuring minimal latency. For instance, if a user in Europe requests data from a service hosted in the US West 1 region, the POP will help optimize that connection. Peering and interconnect. Google offers various options for businesses to directly connect their on-premises networks to Google's cloud infrastructure, bypassing the public internet. Direct peering. With direct peering, customers can connect their network directly to Google at a nearby edge location. This reduces latency and provides more predictable performance compared to public internet connections. Dedicated interconnect. For organizations with high bandwidth needs, Dedicated Interconnect offers private, high-capacity links between their data centers and Google Cloud's network. This is ideal for companies that need to transfer large amounts of data securely and efficiently. Partner Interconnect. For businesses that do not have a presence near a Google data center, Partner Interconnect provides connectivity through one of Google's telecommunications partners. This allows organizations to connect to Google Cloud from virtually any location. Security of Google Cloud Network. Google's network infrastructure is built with security at its core, protecting data both in transit and at rest. Encryption. All data traveling across Google's internal network is automatically encrypted. This includes data traveling between data centers, across zones, and between edge locations and users. DDoS protection. Google's network infrastructure includes powerful defense mechanisms against distributed denial of service, DDoS, attacks. With a combination of edge-level filtering and rate-limiting techniques, Google is able to absorb and mitigate even large-scale DDoS attempts. Private network connectivity. Google Cloud also supports VPC service controls, which allow you to create isolated networks that can only be accessed through trusted interfaces. This provides additional protection against unauthorized access. Google Cloud Resources. In Google Cloud, resources represent the various services and components you use within your cloud environment. These resources include compute, virtual machines, Kubernetes clusters, and serverless compute functions. Storage, databases, object storage, for example, Google Cloud Storage, and file systems. Networking, virtual private cloud, VPC, networks, load balancers, and firewalls. Machine learning and analytics, BigQuery datasets, AI models, and analytics tools. Operations, monitoring, logging, and security tools to maintain and optimize your cloud infrastructure. All of these resources are organized within projects, and they form the foundation of how you manage your Google Cloud environment. Projects. The fundamental organizational unit. In Google Cloud, the project is the primary organizational unit where resources are created, managed, and built. A project serves as a container for all your resources and configurations. Project ID and number. Each project is assigned a unique project ID and number, which helps in tracking and managing resources across multiple projects. Billing and quotas. Projects are associated with billing accounts, and Google Cloud tracks the usage of resources to calculate your costs. Each project also has specific quotas that limit how much of a given resource you can use. Resource isolation. Projects provide isolation between different workloads, meaning resources and settings, such as permissions, in one project do not affect another unless explicitly configured. Use case example. A business could have one project for its production environment and another project for its development environment. This separation ensures that developers working on experimental features don't accidentally impact the live application. Identity and access management. IAM Google Cloud. IAM allows you to manage who has access to your cloud resources and what actions they can perform. It is a central part of securing your cloud environment, ensuring that only authorized individuals or systems can interact with your resources. IAM roles and permissions. Roles in IAM define what actions a user or service account can take within your project. Predefined roles. Google Cloud provides predefined roles with a set of permissions for common use cases, such as viewer, editor, and owner. These roles are broad and cover many services within a project. Custom roles. For more granular control, you can create custom roles that include only the specific permissions needed for a task. Service account roles. Service accounts are used by applications and workloads to authenticate and interact with Google Cloud resources securely. Policy inheritance. IAM policies are hierarchical and can be applied at different levels. Organization level. Controls access across all projects within an organization. Folder level. Organizes projects into groups for better management. Project level. Defines access to resources within a specific project. Resource level. Assigns permissions for a specific resource, such as a VM or a storage bucket. Policy inheritance example. If a user is granted the viewer role at the organization level, they can view resources in all projects within that organization. You can override this inheritance by setting more specific roles at the project or resource level. Service accounts. Service accounts are special Google accounts that belong to your application or VM, rather than to an individual user. They are used to authenticate services, allowing them to access Google Cloud resources securely. Use case example. A VM instance running a web application might use a service account to interact with a Cloud SQL database, ensuring that the application has the necessary permissions to read from the database but not modify other resources in the project. Resource hierarchy in Google Cloud. Google Cloud organizes resources in a hierarchy to allow for structured access control and management. A. Organization. At the top of the hierarchy is the organization, representing your company or enterprise. All Google Cloud resources fall under this organization. B. Folders. Within an organization, you can create folders to organize projects. This is especially useful for large enterprises that want to group projects by department, environment, for example, production, development, or teams. C. Projects. As mentioned earlier, projects are where resources are created. Each project is isolated from others, but you can use IAM to share access between them if necessary. D. Resources. At the lowest level of the hierarchy are the resources, the actual components like virtual machines, databases, and storage buckets that run your applications. Permissions can be set at this level for fine-grained control. Managing access with Resource Manager and Cloud Identity. To further streamline access and management, Google Cloud offers tools like Resource Manager and Cloud Identity. A. Cloud Resource Manager. Cloud Resource Manager helps you manage the resources within your organization. It provides tools for creating, managing, and configuring projects, folders, and organization-level settings. Use case example. An enterprise could use Resource Manager to create separate folders for each department, each containing multiple projects. The IT department could apply IAM policies at the folder level to ensure each department has the necessary access while maintaining centralized control. B. Cloud Identity. Cloud Identity is an identity-as-a-service platform that integrates with Google Cloud IAM. It enables administrators to manage users, groups, and devices across Google Cloud and other Google services. Use case example. Cloud Identity allows enterprises to enforce multi-factor authentication, MFA, for all employees accessing Google Cloud, enhancing security while simplifying access management. 6. Monitoring and auditing access. Google Cloud provides tools to monitor and audit resource access to ensure that IAM policies are applied correctly and to detect any security issues. A. Cloud Audit Logs. Cloud Audit Logs track every interaction with your resources, including API calls, configuration changes, and access requests. This allows you to monitor who accessed what resources and what actions were performed. Use case example. If a sensitive dataset is accessed, you can review the audit logs to ensure that only authorized users retrieve the data. Any unauthorized access attempts can trigger alerts or prompt a security review. B. Cloud Monitoring and Alerts. Cloud monitoring helps you track the performance of your applications and resources, while alerts can notify you of unusual activity or security issues, such as unauthorized access or performance degradation.